Good afternoon, everyone. Welcome back to the afternoon session of the Advanced Aviation Advisory Committee meeting. Again, a few reminders. This meeting is being live streamed and it will be archived on the FAA's YouTube channel at a later date. I will turn it over very quickly to our designated federal officer, Jay Merkel, to introduce our first speaker of the afternoon. Jay?
Thank you, Gary, and it's my pleasure to introduce our Deputy Administrator, Mr. Brad Mims.
Thank you, Jay. Thank you so much. And it's good to see all of you here today. And I'm tired of looking at screens these days. So it's a pleasure. And I really, really, really appreciate you guys who've made the trip to see you. Those who are still on screen, hello to you too. I want to thank Jay and the entire team for making it possible to be here live and or to join us in a virtual space from wherever you may be throughout the country. Now, as for me, I'm very happy to be here live, but with my travel as of late, I certainly understand the need to take part in important deliberations from the road as well. And these are important deliberations. For one, our work, it says your work, I say our work is helping us to advance the Secretary's strategic goals of safety, sustainability, and equity. This is particularly true when we're talking about advanced air mobility. And again, these innovative green electric vehicles will connect communities that have few transportation options, and they'll do it safely and efficiently. We're making excellent progress in making this dream a reality. And just look back 5 years ago, who could have ever thought that we'd be where we are now and trying to move forward in making the decisions that we're trying to make. And just much has happened since we were together in February. The Beyond Visual Line of Sight Aviation Rulemaking Committee provided their recommendations to the FAA, and we held our first virtual public listening session last week to receive feedback on those recommendations. The FAA published the draft interim guidance on vertiports that Shanetta Griffin, our Associate Administrator for Airports, discussed at the last meeting. And where's Shanetta? There she is. And I'm very proud to say that we have Shanetta here and we have Ben White here as part of our political team from the FAA and from the department. And all of us are excited to be a part of this. And I'll tell you, it is a bit of glamour as some of us look at it in dealing with all of this. Now, we also issued new airworthiness criteria for special class category drones. These criteria enable drones to do a great deal of good for the society, particularly with package and medical deliveries. I'd like to tell you that I've also finished up with our expanded list of new members for this committee, but we're not quite there yet. We're going to get there, but stay tuned, and we look forward to getting this done. Regarding Beyond Visual Line of Sight, we all know that these operations are key to unleashing the full potential of drone technology. And we heard it loud and clear from members of the ARC and from you during last week's public listening session. We also heard some sincere concerns about how the recommendations could impact certain types of low altitude aircraft operations. We're dealing with it. You can watch a replay of the June public listening session on FAA's YouTube channel, and we'll have another virtual session as we go forward, public listening session on July 26th. If the notice for this meeting is not in the Federal Register yet, it should be in a day or so. I want to assure everyone that we're looking at all sides of the issue and we're hearing all voices as we prepare to develop policy. And while the ARC report is extremely helpful, our North Star is and always will be keeping our national airspace system as safe and efficient as possible. Now, I'm confident that we'll reach a mature state of beyond visual line of sight operations through a progressive series of rulemakings. And the initial phase will focus on flights at low altitudes and creating drone-specific airworthiness requirements for things like infrastructure inspections and agricultural operations. Follow-on phases will clear the way for more tailored approval paths for package delivery. Over time, we will work on integrating more advanced operations. Phases will build on each other, but I want to emphasize that we will not wait for one phase to end before starting another. We have to kind of be dynamic and move forward as we go. We have to move faster because the potential benefits are only growing. We don't have a date yet for when we'll issue an NPRM for beyond visual line of sight, but we are continuing to work on a strategy, and it is a high priority. I just want to repeat, it is a high priority for us as we're moving forward. Another rulemaking that has captured a lot of attention since our last meeting is the Powered Lift Special Federal Aviation Regulation, or the SFAR. And the administrator and myself have heard a lot from industry. We've heard a lot from some of our members here, and we will continue to hear more as we go forward on Powered Lift. And again, the folks at AVS are moving as fast as they possibly can and being as deliberate as they possibly can. So these rules will set out eligibility requirements to safely certificate pilots for the first generation of advanced aviation mobility vehicles. The FAA will certify the aircraft using existing regulations. And again, I want to repeat that. These new aircraft are being reviewed under our current regulations. All certification work that has been done is still valid. We do not anticipate any delay. What is news is a path for the initial group of civilian-powered lift pilots to have the required experience to obtain a pilot certificate. The SFAR notice of proposed rulemaking, which we plan to publish next June 2023, will set out the FAA's plan for the operating rules that should apply to powered lift aircraft. And SFAR provides for an operating framework on a temporary basis so that we can allow initial operations to and gather more data for permanent rulemaking later. The FAA is determined to make this happen, and I want you to know that we will be leaning heavily on the advice and counsel of this committee for all of these efforts as we move forward. We continue to ensure, and we're committed to ensuring that we have the process in place to ensure aviation safety without inhibiting innovation. This is part of a much broader push from the White House down to future-proof our infrastructure while enabling adaptability and resilience. We want you to see us as a gateway, again, not a hurdle. And with that, I'll let you guys get back to your work, but I just want to emphasize what we're doing is tough stuff here, and we're looking into the future. And we want to make sure that we're not going to get it 100% here, but we will do our level best to make things work and to be safe and make sure that this process is one that we will all be proud of, and make sure that we are holding the American public and others who use our airspace system and make sure that it's very safe as we go forward. So thank you guys for having me over. I'm hitting and running as I'm dealing with my day today, but I want to sit and listen to the discussion today and look forward to being part of much more of a whole meeting as we go forward. So thank you. Thank you, Jay.
Thank you, Brad, and thank you for those words. And thank you very much for taking the time out of your busy day. I know it was quite a logistics feat to get you here, and it will be an equally logistical challenge to get you to your next meeting.
We're going to get out. The next meeting is with the air carriers on 4th of July holiday, and we're expecting.
Wow, I bet you'd rather spend your time with us.
Yes, I would.
All right. Well, thank you very much, Deputy Administrator Mims. And, we're glad, you're welcome to stay as long as you can or as long as you want.
I'll be here for an hour or so.
Okay, perfect. Yes. And with that, Houston, I turn it back to you, sir.
All right. Thank you, Jay, and Deputy Administrator Mims. Thanks so much. And I think all of us on the committee cannot agree more with the DOT's objective of safety, sustainability, and equity. I think a lot of our work, as we talked about earlier, is certainly focused on those areas, and we're proud to continue to support it. So next, I'd like to welcome Mr. Robert Pearce, Associate Administrator of NASA. And we're just so excited to have you here. We had the opportunity, Jay and I, to really say there's a lot of efforts going on in this space. And so to have NASA's perspective, to see what you all are doing, will certainly bring some great insights to this committee so we can continue to bring great recommendations back. So welcome, Bob, and we'll look forward to your comments.
All right. Thank you, Houston. And thank you to the whole committee. It's really a pleasure to be here. I was just actually just in Chicago this morning at the AAA conference. So I just got off the airplane a little while ago. So just to say, it was 15 minutes early. The air transportation system seems to be working just great. So, okay. So I'll give you a perspective on a little bit of just a broad overview of kind of what NASA's up to in aeronautics generally, but then I'll spend most of my time focused on advanced air mobility, the topic of obviously of this committee. So if we go to the next chart. Yeah, next chart, please. Yeah, so and I apologize. Some of these are probably going to be a little bit challenging for those of you at this end of the table. I can only brief them because I actually know what they say, but I actually couldn't read it. But this is just to say this is our strategy. I'm not going to go through it with you, but just to except to say this: we're focused on the future, on where is the aviation system heading, and we do research across the full spectrum of aviation aeronautics, everything from air traffic management in close partnership with and safety in close partnership with the FAA and the community. We do vehicle work, both subsonic, supersonic, hypersonic. So we've got and obviously eVTOLs and all the innovation there. We're putting some particular focus on some of the issues around automation. Is that a really critical aspect for enabling advanced air mobility to scale in the future, but it's also a broad topic across aviation overall as we see the system increasingly automated and in some cases, trying to move towards autonomous operations and so forth. In addition, the whole push towards a more prognostic approach to safety, I think, is a sort of a compendium to that. As we add technology, and especially as we try to increase the rate at which we add technology to the system, we need to make sure we move to a truly prognostic approach to safety, so that we're recognizing the hazards and risks before they become incidents and accidents. And so NASA's trying to do some seminal work in that area as well, in partnership with the community and in support of the community. So a very broad strategy. We update it on a regular basis as our research results come in, and as we continue to have conversations with the community. Because what we try to have this strategy do is represent what we believe the future of aviation actually is. Next chart, please. This is how we're organized. Again, I won't spend a whole lot of time on this, but basically we've got programs that span airspace operations and safety, vehicles, fundamental aviation. We have fundamental research, fundamental innovation, and across the disciplines in aviation and so forth. So that's really just to say that we try to be agile by having a very stable organization that can pivot to what the needs are for the future by organizing generally along these kind of big topic areas. Next chart, please. So this I'll spend a few minutes on this. This is kind of if we had to put one chart up that is our vision for the future, I think this represents the vision. So in the top left there, the issue of sustainability, which obviously is another area that we work closely with the FAA and the community, is front and center. The FAA, on behalf of the entire federal government, published the Climate Action Plan, Aviation Climate Action Plan. We were a part of developing that plan, and we are certainly a major part of helping to enable the actually achieving that plan. And so what we do relative to doing technology development research for large civil aircraft to make them fundamentally more efficient for next generations of aircraft, both from a propulsion as well as an airframe perspective, is key to that. We also, because it's such a big push, the work we did, we are continuing some of the work, and I'll talk about this a little bit more. We had a big push, with the FAA on next gen. We had sort of completed most of that work, but this gave us an opportunity to actually continue some of our trajectory management work to actually look for integrated, trajectories end to end versus, the work we had done relative to sort of departure en route arrivals and so forth. Now we can start to look how you would integrate that and again, in partnership with the airlines and industry and so forth. So we're looking at that, and we're doing some work to help support the transition to sustainable aviation fuels, combustor work, other things that enable 100% use of sustainable aviation fuel. So it's basically every aspect of the pathway to sustainability, to net zero emissions. By mid-century, we have, some hand in terms of doing the research, doing the technology development, again, in close partnership with industry. One thing, if you know us, and many of you do, but if you don't, we are a research organization. If we just sit in our labs doing this research, none of it matters, right? So almost everything we do, we try to do in partnership so that it becomes reality, so it actually gets out and gets commercialized, gets used, by the aviation, the folks that actually operate the aviation system. So partnership is really critical, and cost share is also critical to make sure that we're not just pushing technology, but folks at the other end are pulling on technology. Right below that is at the other end of the spectrum, high speed. So can we get back to a future that includes high speed flight? So supersonic, hypersonic, huge hurdles to that, especially as you look at a more, if we're moving towards a more sustainable future. Those systems, are inherently higher energy, to require more energy to operate, and so we're doing a lot of work there. Noise is a big issue. So the big thing we're doing right now on supersonics is trying to reduce overland supersonic noise. We actually know how to do it. Now we just need to determine if the level of noise we can get to actually is acceptable to communities. And so we're actually in the middle of building an X-59, and some of you are aware of that. Some of you have seen that. It's getting really close to flight. It's pretty exciting. So hopefully by the end of this year, if not early next year, that airplane will be in flight. And that'll actually allow us to get out and fly over communities with this very low sonic noise. We call it a thump. Maybe the sound of a car door closing next door, if you're paying attention, kind of that kind of a noise. But we need to dem it right. We're working with the FAA. All the ground research in the world isn't going to prove that it's acceptable to communities. And so we have to go out and fly it. That's what the X-59 is all about. We'll fly over communities. We'll generate that database of what the acceptability is, and we'll deliver it to the FAA and ICAO to see if we can't get a rule. And then from there, we'll move on. There's a lot of other challenges in high speed. I'll go to the top, future airspace. Let me start at advanced air mobility. I'll talk a lot more about that, but just to say, huge focus of ours, and the rest of the presentation really is around that. But I want to just stop there, because if you think about, subsonic, supersonic, AEM, which is low speed, if you think about high altitude, long endurance, UAS, and so forth, the future of the airspace is much more complex as we go forward. The FAA has recognized this as an XTM future, the model for the future and so forth. We're right in line with FAA's vision, and we are extending that vision to even longer term. And so that's our next big leap beyond the support we made, the research that we did in support of next gen. The next big leap is to really take that mantle around XTM and actually apply it to these new challenges around AAM and high altitude and so forth, high altitude airspace and that kind of thing. So make sure we've got an airspace that can actually accept all of these new innovations. And again, the other part of that, the other side of that coin is safety paradigm that actually allows us to understand what risks and hazards those technologies might be adding to the system, so that we mitigate those before they become incidents and accidents, so that there's no impact on safety. In fact, hopefully we get to an even safer airspace system as we go forward. Next chart, please. And stop me anytime if you have questions. So I just wanted, just as background, so we got into the area of advanced air mobility through the work we did with UAS, which obviously many did. That was the stepping stone, right, to AAM. And so we had two big projects. One we called UAS the NAS, which was essentially mid to large UAS that wanted to operate in the airspace and Class D, Class E type airspace. And so we completed that project, and we also did a small UAS traffic management with small, drones operating at low altitude, 400 feet and below. So we completed both those projects. I have a chart on each. So next chart, please. So UAS the NAS, you can see, what we were trying to do is help the community develop the standards, especially around things like detect and avoid, command and control communications, and developing, developing the definitions around things like well clear and so forth, that would give and actually go out and fly those, so that the standards committee actually had hard data upon which to develop and validate and publish standards. And so that's exactly what we did. You can kind of see the thing again, working with RTCA and others on detect and avoid, command and control. You can see the well clear there. And again, we did all of this in a flight environment that was a mix of virtual and actual flight assets, so that we could do the complex type of interactions that would be required to actually prove this out. All that was delivered very successfully to RTCA, and I think we did a great service to the community in delivering all this information. On the bottom, there is a link to our closeout technical interchange meeting, where we captured all the papers, all the information. So if there's interest, all of it is captured there, and it's available to you and the rest of the public. Next chart, please. Similarly, on UAS traffic management, this was a very innovative activity where our researchers got together and took their sort of domain knowledge of air traffic management, and then looked at how would you develop air traffic management on a modern service-oriented architecture, right? So a modern network architecture, and successfully did that as well. And we did 4 major integrated flight tests with the community, starting simply, rural area, in visual line of sight, going to ultimately to urban areas and beyond visual line of sight type operations. Again, taking all that data in a very disciplined way, developing, papers and information data sets to go to standards committees, to go to the industry and so forth. And UTM obviously has now become it's like Kleenex, right? It's like, it's become its own thing, right? What's the nice thing is the community has taken it beyond where we left it, right? And it continues to develop. But it also, for us, is, I think it is the basis of now what FAA calls XTM, the idea that extensible traffic management, and taking this, the idea of a modern network architecture and looking at domains in different ways, and developing an air traffic management, a more collaborative air traffic management system, more data focused air traffic management system around that. So we took that lesson in spades out of this, and we are applying it as we go forward to AAM. And again, you can see all that data is available to the community, and at that hyperlink down there. Next chart, please. So just a chart that says we're proud of what we did, and we're certainly proud of our partnership with FAA and the industry. Next chart. So advanced air mobility. Next chart. So I don't really need to talk too much to this committee about all of that, but suffice it to say that there is a tremendous number of potential business models, potential operational models that can be served by the kind of technologies that industry is developing in this broad space of advanced air mobility, whether that's eVTOL or eCTOL, and so forth. So, obviously operations in urban areas, urban to suburban, urban to rural, regional transportation. And I'll talk even a little bit about things like wildfire and so forth. There's a lot of applicability of this kind of research to many different domains, and that's what we are at NASA. We're trying to find what are those, and really focus on those areas that are most enabling to the largest number of these kind of business models and these operational models and so forth. Next chart. And so again, this is a categorization of different models. There was some just earlier, some talk about the public good aspect of this. That's certainly the one we're most excited about in terms of the ability for, innovative uses in the healthcare system, uses for wildfire and emergency response management and so forth, in addition to the big economic drivers around passenger transport, cargo transport, and so forth. And so there is a huge potential for advanced air mobility, but obviously, as everybody in this room knows, a lot of work needs to be done to be able to do more than, a few operations at a time. If it's really going to deliver the kind of, hundreds of billions of dollars of economic potential, it's got to be something that can be done at density, at scale, with, where you're carrying lots of goods, lots of passenger, you're delivering a lot of benefits. So that's the key. That's what NASA's focused on, is that path to scalability. Even as the industry is focused on, certifying those first products, NASA is really trying to look forward and say, okay, how do you take those first products and how do you get to that scalability so that you can operate at, again, very high densities, very high operational paces and so forth, and make sure that's safe, secure, it has community acceptance and so forth. Next chart. So this is our, kind of our vision for this, across the major domains of vehicle development operations, airspace design and operations, and community integration. What we're trying to do is really take a three-prong approach to this. One is the research we're going to do, right? We've got a research and development portfolio focused on what we think are really challenging issues, where NASA has the capacity and capability to do that work, and we are best positioned to do that work. And again, do that work in partnership with others. We are sponsoring a set of ecosystem partnerships, ecosystem working groups, where we're trying to bring the entire community together so that both we, but everybody understands the broad range of requirements, needs, opportunities, and so forth, and to encourage partnership amongst all those players. We certainly will participate in some of those partnerships, but we expect those partnerships to be much broader than what NASA can support. We have obviously limited set of resources, limited set of capabilities, and so we will partner where we can make the most value. And then we've got our national campaign series where I'm most excited about, where we can bring the entire community together, not just to talk, but to fly, to actually bring capabilities together that we've been developing over time, whether it's FAA, whether it's NASA, whether it's industry, create an environment where we can integrate, go fly, and actually do that in a very disciplined way. So we're taking data, we understand, how close we are to our expectations as to where we should be, what the gaps are, what the research questions are that we learn from that, what the technology needs are, and so forth. So that's, we want to operate that national campaign series as a learning exercise for the entire community. And that's certainly our goal there. We're sort of right now in our, what we call National Campaign 1, which is sort of a starting point. And I'll talk a little bit more about that, but National Campaign 2, I'll talk a lot more about, because that's, I think, where we really start to get some traction on tackling some of these hard issues. Next chart. So these are our North Stars. For us, we're trying to be as focused as we can. So automation, airspace safety, and noise. You notice all of those are really system-wide kinds of issues. So it's the kind of thing that no one organization can do themselves, where NASA has quite a bit of capability, and where we think that through providing our research capacity and capabilities, we can actually help the community move the ball. Again, as well as you can see, those aren't things we can do, even if we wanted to, we couldn't do on our own, again, because they do cut across organizations. All of those things, you'd probably say, we got to work with the FAA, and you're absolutely right. We are working with the FAA in each of those topic areas. We have agreements with the FAA. We have a committee that we meet with regularly with the FAA to make sure that everything that that NASA is doing is understood by the FAA, and FAA has the opportunity to influence us, and we certainly have the opportunity to line up to FAA roadmaps, but also to influence the FAA and their thinking in this as well. Next chart. So this is how we're laying out this national campaign, which I think about as a centerpiece to what we're doing in advanced air mobility. Again, NC1 is really around those initial, getting familiar with the community and the types of vehicles that are being built, their ability to do things like trajectory conformance, learning how they, their noise profiles, things like that, all that helps us better model, which is really a key for us, being able to better model those vehicles and their attributes so that we can do better simulation on a system-wide basis. And so that's kind of what we're getting out of those first increments of within NC1, and I'll show you the partnerships we have there. Going into in NC2, and you see we got quite a gap between what we're doing in NC1 and NC2. And the reason is that what we've sort of decided there is that really what we want to focus on is the integrated systems across vehicle, ATM, and vertiport. So, all those elements play a key role to how this system will operate on an integrated basis. And so we really wanted to understand those systems, especially the automation, the functions, the performance, and so forth. And when we do that, then we can really get a sense and what a sort of an integrated architecture would be around that. And then we can derive from that, what are the key research questions? What are the technology opportunities and needs? And then that'll help us better organize, but hopefully it'll better organize the entire community to line up to what would be in our, the way we're thinking about it as a to-be architecture for a 2030s and beyond future that really can support high tempo operations, high density operations. That's really the focus, not the nearer term early operations, but really that longer term. But we also want to know obviously what the near term is, and so we really then can look at the gaps between the near term and then what the to-be state is for that 2030s and out. And so we're doing that now. We've because of the work we did with Uas Traffic Management and then the application of that to PSU, right, the provider service for UAM, we have that architecture. Now we're adding in the aircraft and the vertiport to that. So we're starting to flesh out that entire architecture. We're going to be doing that again in partnership with the community. Once we get sort of agreement that that's a good starting point, it's not necessarily meant to be the answer, but it should just be a good starting point that we can really derive our research questions. Then we can really go and work hard towards those questions, and hopefully we can get some good alignment between all the players. And then when we get to the NC2, what we really like to do is then fly a prototype of that integrated automation system. So that's the idea. So that's going to take a few years. And then beyond that, we can then start to look at taking that and applying it to things like high density vertiports, urban operations and so forth as we get out to 2030 and beyond and really get to that scalability. So that's kind of our vision for how we move forward using that national campaign to drive us. Next chart, please. And so there's a little bit more detail on NC1, the timeline, and NC2. And again, going into like those big flight demonstrations, there's a whole series of simulation exercises that we run. We're doing that today for around those early iterations around the PSU, and we'll be doing it in a much more advanced way as we look at that baseline automation prototype out in the 26 timeframe. So while 26 is a few years away, along the way you're going to be seeing a lot of opportunity to partner up and to work with us on those simulations. Next chart, please. Yes. Yeah. Please.
You had me at hello with this pitch.
Yeah.
Which is cool.
Good.
The time, but then you lost me on this timeline.
Oh, okay. All right.
Like lots of us in industry are looking to scale way before the 30s, and so are we going to run really fast into a brick wall? Is that what's going to happen?
Well, we are trying as best we can to respond to the timelines that industry is putting out there, but there are, at least relative to our ability to resource and so forth, there are just fundamental limitations how quickly we can move. But that's why we're trying to get out far enough that we're not getting in the way of industry and your early operations, but trying to get out far enough that, we're building towards a, where you could be flying, say, thousands of operations in an urban area, that kind of architecture. So something that's a little bit further out. Now, I understand that some would like to be doing that sooner rather than later, but I think that's a broad conversation for the community to figure out.
Yeah, I think we
how
need
quickly
to have
that's
that
feasible.
conversation, because by 2027, lots of us won't be here if we're not doing millions. So there's a disconnect there that we need to understand. Thank you.
Yeah, no, and I appreciate that. Yeah. Yeah. Good. Hopefully I'll have you at goodbye. Yeah, and everything in between, right? Yeah.
If not, we can give David one of your UTM tissues.
Okay, good. Yeah. Yeah. Well, not to digress too much, but anywhere you go in the world, like people wear NASA shirts, and I just like, if we could just get the rights for that, I could fund all this, no problem at all. But unfortunately, we're not allowed to do that. So anyway, this is our early partnerships right now for NC1. You can see several partnerships. Joby Whisk, Reliable Robotics, others that we're working with, doing some flight. Some of it's around noise measurement, again, so we can get better models for noise. Noise propagation and so forth, and so we can really understand what community noise might look like, and again, working with the FAA to look at how that would affect potential community noise standards and that kind of thing. Looking at flight procedures, the ability to fly trajectories and so forth, maintain trajectories. We're looking at airspace management. Your early airspace management tools and architectures and so forth, things that would support early operations. And let me just say, I mean, as I said, we're focused on that long term, but the whole idea is to spin things off along the way, so that so the first product or first research result you see out of NASA is not way out in 26. They're all along the way, that working with the partners so that the early PSUs have the opportunity and the results of, because we're working with them on these simulations, and so the kind of things they want to do early on is supported by what we, our research. Next chart, please. So this is, getting to kind of what I was talking about. So what does that, what does that automation future look like, including system-wide safety and so forth? So the airspace, the fleet management systems, the vehicle, the ComNav and surveillance, the vertiports and so forth. All of those have elements of systems and automation that need to work in an integrated way. And so we're trying to, again, lay out, what does that architecture look like? What are the research questions that need to be answered? And what are the technology opportunities? I guess the other answer to your question, David, is I think our hope is that if we can get good alignment to what we think that to be is, we can accelerate, right? Because then everybody's working towards a common perspective, and we're not going off on sort of divergent pathways, right? So I do think that is a benefit of working this way. Next chart, please. So just an example, this is work we did with Joby. You can kind of see us, our NASA van there, that we have a NASA capability, can go out in the field and do very detailed noise measurements. And so, this is just a way of, again, building up models. We've got really quite good analytical models. To begin, we've been doing vertical lift research for decades and decades. And so we've got really good baseline models to begin with, but these eVTOLs are different, right? And so we've been updating those models. Getting flight data is greatly beneficial to validating that the updates to our models actually work. And then we can apply those models to more community-wide predictions, and then we can start to take a look at what those community requirements might be around noise. So it's a very closed loop in how we do this research. The more we can do these flights, the more we can get additional partners and understand the characteristics of different vehicles, the better our models are and the better we can predict community noise impacts. Next chart, please. And of course, we're doing our work as well on low power, lower power, eVTOL type power, electric propulsion. So we've got our X-57 distributed electric propulsion demonstrator. It is, we are on the verge of flying. We're going to fly here in just hopefully next month, in September. So not quite next month, but soon. We're at the sort of the final, issues that you run into when you're getting ready to fly. The kind of the last one was on electromagnetic interference. We've solved that. Now we just need to kind of button things up and get ready for flight. It's taken, for those who have been following, it's taken quite a while to get to this point where we're flying. But part of the reason is because we've been doing this in a way where everything we do is very open. And we've been taking the time to document and provide that information to the community. So we've learned a lot, and we provided all that information out to the community. But we do want to get to that final exam and actually get the airplane in the air, and that's where we are at this point. And so we'll be flying, and then we hope to wrap this up in at the end of next FY23. We'll see if there's additional interest for partnership with industry. Maybe there's a possibility to extend, but that's kind of where we are on that. Just as a note, in addition to this, on the electric propulsion, we are actually working we're working megawatt class electric propulsion as well for large aircraft, which is also very exciting as well. And we're going to get to flight on megawatt class and kilovolt class electric power in the 26-27 timeframe. Next chart. I did want to just speak briefly, like I said, one of the things that we've been able to derive from this, and we actually derived this from our Uas Traffic Management experience. We took what we did in Uas Traffic Management, we basically put it in a box, and we went out and to the field with the wildfire managers and said, let's see if we can't control some small UAS while the large aircraft are operating at the same time. Because as I think most of you know, when the large aircraft, that are dropping retardant or flying and so forth, you can't fly small UAS because the air boss can't see them. Well, if we can if we can do put a P kit out there, pilot kit and so forth, and provide that situational awareness, they can fly together. So we've done that, and it's been so successful. We actually have researchers soldering together more P kits to get out to the field and so forth. So what we did is because of the success of that, we actually, had a couple of workshops with the wildfire management community. We kind of got what they would like to see relative to enhanced aviation capabilities in support of that. And then we went to our stakeholders and said, hey, this is kind of stuff we can do. We've got that kind of, and the community has this kind of capability. Let's organize, develop the concept of operations with the wildfire management. Let's go do it. So we got, we got permission to go do that. So we have a next year in the FY23 budget, we have a request on the Hill for $8 million. We got our house mark, and they said, why don't you do $10 million? So I think we're getting some support from the Hill on this as well, to the kind of things we can deliver. So I think the next chart actually has just a little bit of detail. Yeah. So again, a kind of an eye chart here, but we're looking at all aspects of how you would manage these assets so that you could do day and night operations, you could do more high density operations, and because our science mission director inside NASA is a sister mission director at the aeronautics. They already supply satellite based imagery to the wildfire management community so that they can look at they can get some surveillance. Of course, we can do more timely surveillance with aviation assets. And so we'll do that. But working with the science mission director, we can also start doing things like fusion of all this information to provide better modeling capabilities for the wildfire manager as well. So we're pretty excited. We're moving forward with that project going forward. Next chart, please. And then, this what we're calling Sky for All, but where we're heading with airspace. Next chart. It's we're working closely with the community. You can see this is kind of the way our chart, trajectory is meant to be, read next gen, right? That's, there's fundamentally a trajectory based management system. As I said, we're going to continue to do some work in order to get the more sustainability benefits out of trajectory management capabilities. That middle box collaborative is really in line with infocentric NAS that the FAA talks about and that we're lined up to. And then we're looking even past that to a more highly automated future where, as AEM scales up, as the traffic gets more complex, as we might get new vehicles like high speed and so forth, the system gets more complex, and you're going to need more scalability. And so you're going to need more automation in order to make all that happen. And so those are the kind of things we're working on. And at the same time, those prognostic safety that can operate on that same sort of information layer, right? So all that information will be available to also to look at things like, how do we do prognostic safety? How do we mitigate incidents and accidents before they actually become, or mitigate risks and hazards before they become incidents and accidents? Next chart, please. And so we're going through a process with the community to look at all of these futures, get the best ideas, and then organize and go forward. And again, we're doing on this under this kind of Sky for All banner. So many of you probably have already had some interaction with us on this, and we'll continue to do that over the next coming months. Next chart, please. Last thing I wanted to just talk about is a little, maybe, well, I talk about it because I think there is alignment with this. It's broader, but next chart, please. And it's really around our University Leadership Initiative, which has been wildly successful. And actually, this gentleman here that I'm sitting next to, Jae-Won Shin, back in the day when we were working together, when he was in my position, we dreamed this University Leadership Initiative up, and I don't think either of us, or, maybe Jay did, but this has really been just wildly successful, and we're really proud of it. And the reason I bring it up is because what we ask the universities to do is just go and come up with topics that are relevant to NASA's strategy, but get your own ideas out there, and we'll fund you at pretty high levels. So a couple $1 million a year over a few years to really solve problems. And so we've got several that are out there working the advanced air mobility issue, some on the vehicle side, materials, but some on the automation side, like how do we validate autonomous systems, some on how do we do the air traffic management. So there's a really active university community, and I would just encourage industry folks. While we want the universities to lead, we also want them to partner. And so feel free to reach out to these folks and be part of those teams. It could be very minimal lift. It could be just be part of their advisory committee, those kinds of things. It really helps them. Yeah.
For us to be a little more inclusive as we're going forward, we want to make sure that we have some of the minority serving institutions as part of it.
Yeah, we've got it. And thanks for saying that, because we're really proud of the fact that we've got about 25% of the universities that are part of this are either HBCUs or MSIs.
Okay. All right.
Yeah,
appreciate it. Thanks.
We've spent a lot of shoe leather getting out and talking to universities that have never worked with NASA, let alone aeronautics before. And so it's been amazing that, a lot of us thought, well, the big schools, the MITs and the Stanfords and the Georgia Techs would, kind of walk away with this. But some of the smaller schools came up with awesome ideas, and we were so happy to be able to award them. And the big schools were actually behind. They thought, we got that, and they kind of just phoned it in, right? So now they're catching up. They're starting to get more awards. But this has really been fantastic. But I absolutely agree with you. Okay, and I think that's it for me. I could talk for hours, obviously, but I guess maybe just this last summary chart next year. And that's just to say, we've right now where we are in our sort of, our history is we have more demand for partnership in NASA aeronautics than we could possibly keep up with. And it's all because of the amount of innovation happening in aviation. I know FAA is feeling it. We're feeling it. The industry is moving, David, as you said, you want to go as fast as you can. We want to support you to go as fast as you can. It's just, man, it's hard to keep up sometimes. So anyway, thanks.
All right. We'll take some time. First of all, thanks so much for a fantastic presentation. I do want to note one thing before opening up to questions. I was just taking some notes, and it was very interesting. And I know David and Salita, you'll appreciate this as you talked about the tasking that Jay gave the team in terms of that roadmap, for UTM. And I just noted, Bob, that you had in one of your slides, you talked about airspace, infrastructure, operations, aircraft, and community. Those 5 focus areas that we've been asked to come back with are very much aligned, with what NASA is doing. So it's just great to see that synergy. And I think that was one of the things that Jay and I talked about was, making sure that we're aligned, with the activities going on NASA's and other groups. So just hearing that, and I understand the pace, Dave, and everything else that'll kind of come right in different areas. But I also heard concurrent activity, right? Which is some of the things we said we know is important. So, and safety, of course, along the line is most important. So just want to kind of draw those connections there because I know you guys are running, but it's really good to hear that alignment. So Kenji, I'll turn over to you.
Rob, thanks so much. You had me at those graphics. Whoever does your graphics, I'm always amazed at what NASA does. But you mentioned infrastructure on page 69, and you, in the next couple slides, you talked about megawatt class aviation as well. And Carrie, we had this discussion right before lunch. And but my question is, are you conducting research in modeling of energy infrastructure requirements for alternative fuels? Because we're talking about electrification, you're talking about AAM, you're talking about traditional aviation as well. There's power generation, there's power delivery, there's storage. Even Jaywan, you mentioned earlier about real estate. And of course, infrastructure is going to drive real estate and siting as well. So have you done modeling into what's required for all this infrastructure and all this aviation?
Yeah, it's a great question. We have done some, but certainly, we're not NASA's not the experts on energy infrastructure. So we work closely with the Department of Energy as well, trying to get their insights as to where the energy infrastructure is going. One thing we are doing is as we look towards that sustainable future, sustainable aviation fuels is certainly the kind of the first, is the major strategy because it's a drop in, you get fleet-wide benefits right away, but there's a lot of push towards other energy sources, hydrogen and other things. There's especially in Europe and so forth. One of the things we're doing because we're trying to take a very objective view as to what are the potential energy propulsion futures that are out there. So it could be hydrogen, it could be other source, it could be electric or, various forms of electric and so forth. Maybe it's forms of methane, ammonia, whatever the case might be. We want to be a little bit agnostic and objective and just start to look at what all of those are. And then working with the DOE, we can start to look at how does that match up to where the energy infrastructure is actually going? Because aviation would be the tail wagging the dog, right? If we say, hey, we're going to go off on this vector all by ourselves, we'll probably end up at the end of a really thin branch that'll break off because we need to be in line with where the overall infrastructure is going. And so that's why we're working closely with DOE on that. But we want to sort of, again, take that objective view. What are all the possibilities? And then how does that impact, let's get the best climate science. Let's look at how that best serves climate. And then how does it best match with, the infrastructure? So we're with you. We and do it on a life cycle basis. So we're with you on that question. And it's just, for us, it's just going to take some time, I think, to maybe do that objective assessment.
Yeah, and I appreciate that because one of the things, it ties into what David was saying earlier as well. A lot of these infrastructure projects take years and years and years to complete and plan, and it has to go through environmental analysis too. So if we can get that done as soon as possible, the earlier, then we can talk earlier than 2030. But even right now at 2022, that's only 8 years away, and we know it can take decades.
Yeah. We have done some on the AAM side in terms of looking at the electric infrastructure and so forth. Others, I think, have probably done more, but we just did, as the entire transportation system electrifies, as you probably know, it can get pretty tight. So it's a market, right? So, it's the prices will go up and, demand will demand supply will balance out. But, but it will give a signal that more green electricity is needed, whether it can be produced or not is, I guess, the question.
Oh, no, go down to David.
Great. Hey, Bob. How you doing? The SFNP is a great example of the FAA and NASA and other bodies working well together. I think there's no doubt that there's a lot of successes to point to there. I guess the question is for you and to some extent for Brad too. UTM, when you guys launched on that project, I think there were a lot of lessons learned in terms of how it was passed over to the FAA. There was a lot of, use my words, a little bit of discord to begin with as to, how that work would transition. What are the lessons learned from that? How do we see the AAM work statement as it, how it gets passed over, when it gets passed over. Is it done in a gated way? Is it, periodically? So to David's point, that we can accelerate as we learn things. How do you think the relationships are there now to make sure that we're more moving in the same direction at the same pace, at one time? So
I certainly think so. We did learn a lot of lessons out of UTM, and you're right that at first there was some cross communication there, but we quickly developed the mechanisms so that we were sitting down through what we call research transition team process to share learnings, to make sure that we fully understood requirements from an FAA perspective, from an industry perspective, and so forth, so that research is aligned. So we've taken all those lessons and we're applying it here. So we're in regular communication with the FAA. We sit down monthly or something like that to make sure we're discussing, and we're not always going to fully agree, but it gives us the opportunity to make sure we're in best alignment as possible.
And in that whole process too, I want to make sure that it's clear that FAA is working with our leadership team within the department and the Department of Energy on various things, so that we are harmonizing it as we go along and doing the things that we need to do to make sure that constructive communication is taking place.
Bob, just a quick thing. I'm sure you know, but did you see the announcement that the Air Force just put together a new UARC for autonomy, and it's focused on HPCUs? So that was just an announcement that came up this week.
I did not see that.
So I think the ULI could team up.
Yeah.
So Victoria Coleman, the chief scientist, is trying to work on all the details, but that could be something that there could be a great synergy between NASA and the Air Force.
Yeah, thanks, Robbie. We'll look into that.
All right. Any other questions? Okay,
Yeah,
Jeff.
Jeffrey, question for you. Thanks for the presentation. But my questions around noise, I think it's probably intended both for NASA and for the FAA. At the airports, when we measure noise, we measure it based on DNL. The two questions: first, I noticed that your noise measurement was based on dB, which seems to be a single event. But importantly, in the future, as you gather this noise data on the aircraft, would that be used to inform the FAA's AEDT tool for calculating noise, and how will that be done?
Yeah, so we have we've developed an agreement with the FAA on how that's going to work. I don't have all the details off the top of my head, but one of the things is that the frequency characteristics, and we got to understand. That's why we're sort of working on in basic units, right? Because we're really trying to understand loudness, frequency, all of the components, because it's very different than traditional aviation, and the proximity to and the flight paths and so forth are all going to be different. So we're trying to really get all those basics so that we can inform things like the ADC model and then start to predict. So unfortunately, I don't have the details of the agreement we have with FAA in front of me, but that's the whole idea. Yeah.
Yeah, because I think what's important, because if the approach into the airport for electric aircraft or eVTOL aircraft is going to be different from a traditional aircraft.
Yeah.
So your noise profile is going to be changed,
Right.
and you'll be able to communicate that. So you can.
Yeah. So I suspect traditional, DNL contours and so forth probably aren't applicable in the same way, right? We got to develop it, something that fundamentally addresses what would be an annoyance,
Yeah.
to folks, with this kind of technology.
Yeah, I think it's important when you're using metrics. If you're saying dB and DNL, if you speak in two different metrics to the community, then they become, exactly what you're talking about. So we need to be consistent.
Yeah. Our noise experts speak that language, so they can do all that.
Thank you. Well, thank you, Bob. As always, great presentation. But just some words for Bob. Bob's doing a great job. so I think
I didn't pay for
NASA
that.
Aeronautics budget. Yeah, you don't have to pay me for saying that. But NASA Aeronautics budget, I think, under Bob's leadership is growing tremendously. So it's a good testimony for good leadership. But let me just offer a little bit of a philosophical and fundamental comment based on some of the earlier discussions about timeline and can we actually pull this together? It's so complex and so on. I have been in a somewhat unique situation that shuttling back and forth between Korea and here. So I got the perspective of how people outside look into us, U.S. government and industry and so on. So I think it's really, I mean, I really don't need to impress you that this AAM and sustainable aviation, all these things, we cannot lose our U.S. global leadership. In Europe is really trying to regulate, as you all know, into a sustainable aviation. And as far as our market studies, we've done a lot of market studies. And based on that, it's real. It is not something just gonna go away anytime soon. But again, looking from other side of the pond, the general impression about our government and U.S. is generally we're slow. We are sort of not opposing, but we're kind of questioning whether that's going to be really the future or showing some reluctance and so on. I think that's the fair characterization of how Europeans and like Korea and Japan are looking at the U.S. So because of that somewhat unique situation that I've been exposed to, I feel we have to really double up our effort. I mean, FAA and NASA have been working so well that I'm very happy to see still we are working very well. But industry really need to come together with a government because again, we cannot lose this market, whether it's a drone or AAM or sustainable aviation. We just can't afford losing this global leadership. So sorry to be a little bit more philosophical here, but I just wanted to offer that perspective that I've been exposed to.
I appreciate that. And Bob, it's high praise when J1, your predecessor, says you're doing a good job. And David, I about a decade or so ago learned to listen very closely to what Bob said when he was mentoring me. One thing Bob said that I want to add a comment about these transition teams. When we were doing things like Next Gen and CTAS and all of that, it was predominantly a tech transfer to the FAA alone. And now with UTM, and I think one of the things that caught us off guard is we, the FAA, weren't accustomed to being in a place where it was both some tech transfer to us and some tech transfer to industry. And I think that's probably a very important lesson. And you listen, Bob talked about, it takes all three of those. And I think we need to be very mindful that not all of what NASA is doing is going to come to the FAA. A lot of it comes to industry. And I think as we look at these more advanced autonomous ways of managing the airspace, the ANSP will obviously have a role, but I think industry is going to have a role too. And I think integrating that with your new platforms, your new aircraft is going to be very, very important. You know, I don't think you'll be putting NDBs on those aircraft, right? But the other thing Bob pointed out, which I think is an increasingly important conversation in this community, is the digitization, if I said that right, of the need to really make information exchange in the airspace much more digital. We just can't get to scale if it continues to be push to talk around radios. And so there's some really important nuggets in there.
So Jay, and kind of doubling down on that, I think that's the part where Bob and industry have already demonstrated that the technology is there. So this is not a technology challenge. This is a change management problem. This is okay, it is a problem, but let's call it a change management challenge because I am the eternal optimist. But that's going to take all of us. And that's going to take, and it kind of goes back to what Jeff was talking about with community, and what Dave was talking about with community in the tasking for AAM. We've got a huge change management moment on our hands in this gorgeous renaissance of aviation, but we've all got to be like all in and really, and putting forth the goods, the stories about the benefits, so that average John, Jill, and Pat Q public see themselves in it. Thank you.
Excellent. Well, great discussion. Certainly, Bob, I want to say thank you for taking the time. I think it might have been a few months ago, we shared the study that the National Academies for Science, Engineering, and Medicine had put out, which was the consensus study report advanced aerial mobility. And I think if you look at that study, if you haven't had the opportunity to read it, I would encourage you to do so, because if you look at the national blueprint, everything that Bob's saying, the activity and collaborations going on with the FAA, what we heard from airports, you can see all those things merging, under congressional support. So this is real activity that's taking place, and it's very encouraging, Bob, to kind of hear that perspective and to kind of see them work. And some of the activity that we're being tasked to do to support it, should be very exciting for everyone. So certainly thank you, Bob, for taking the time to be with us today. And with that, I'd like to move on to new business. I want to try to keep us on time, Jay, if we can. So I did mention that we had several new business items that were brought up. We cataloged all of those items. So if your item's not up here, by all means, we're going to pass those along to Jay. So there'll be opportunities. But I did want you, if you go next slide, please, at least give those the opportunity to kind of have a conversation, in a couple of these items. So one of the areas that kind of came up was UAS, AAM, operator security. And I want to kind of temper this as we have a quick conversation, because from a scope perspective, we also want to make sure that things that we talk about are within the scope of what this committee is responsible for. So I know, within the committee itself, there's a lot of, concerns about drones being shot down and things like that. And I certainly share those concerns. But in terms of the work of this committee, in terms of what we're going to put our energy to solve for, I just want to make sure we temper the conversation, appropriate. So with that, I would open it up. I know there was some AAM security issues separate from that came up as well, in terms of, passenger vetting and things like that. But certainly would open up to the committee for any conversations along that first new business item.
I guess I'll start this off. Yeah, I understand that I've talked with Jay about this, and it's not necessarily within the scope of the CCC, but it's obviously a priority for all of us. A number of people here in the last couple of days have come to me and said that they're surprised by our email exchanges. And it needs to have a focus of some kind that is interagency. We've been part of a few of these conversations. I myself have been part of a few of these conversations with people who have been shot down, shot at, attacked. And it gets to the bottom floor of the DOJ or the DOTOIG, and it just gets shut down. So if we can figure out some way to work with them, the FAA, DOT, DOJ, and figure out a singular process to where, okay, you get shot down, you get shot at, you get attacked. Where can then we go as a community, whether it's recreational or non-recreational? Where can we go as a community to where it's an easy process, because nobody knows what to do? So that's kind of where I would kind of like to take this if possible.
Yeah. So what I would think, Vic, and thank you. I know this is definitely an area of concern, so I don't want to dismiss that concern at all. But what I would recommend, we'll kind of take it offline. And then Jay, maybe we can kind of work and say, hey, where's the appropriate place for this to reside?
Yeah, exactly.
And connect some dots.
I think we need a three-way conversation with you, because this committee may not be the right place to do that tasking.
Right.
But I don't want it to fall on the floor. Right.
Right. And I know you've sent one of my emails up the chain.
I read all of them. I read all of them.
Right.
So yeah, if this could be a priority between you and
And
me and
it's
whoever.
not just you,
Oh, I know,
the
I know.
utility, the major
Yep.
utilities doing work, and they
David
do a
brought it up.
lot of community outreach and in advance of their operations, and they
Mhm.
still have these problems.
Right.
So,
It's not an education issue. Definitely. It's a proactive enforcement issue. So yeah, if we could promise to take this offline and do something, that would be phenomenal.
yeah, that would be great. Yeah, happy to do it.
Absolutely.
Awesome. Thank you, sir.
And this kind of ties back into the roles of, federal, state, local, that whole conversation that we tackled early on as a
Yeah.
committee and really struggled with, quite frankly.
And also the interagency aspects.
Absolutely. So,
Right. Right. Because
but
the
thank you.
locals don't know what to do with it.
exactly.
So,
Yeah, but
yeah.
thank you, Vic. Yes, Captain.
I think one of the things we really need to do here is we need to wrap this discussion into the White House counter drone strategy, where it was talking about putting in laws, federal laws and enforcement, so they're clear enforcement actions. And also it was in that white paper on the counter, it specifically says work with Congress to enact comprehensive criminal statute that sets clear standards for legal and illegal uses, et cetera, establishes adequate penalties to deter the most serious UAS related crimes, et cetera. I think that that is a place where it needs to be us with Congress and the White House. So I think this is way above and beyond.
Yeah, and Kathy, there's an upcoming event that I think a number of you will be invited to at the White House, and these security issues are actually on there. So I'll let them know the interest level here as well.
Yeah, and Jazz, I see you have your
Can
hang
we-
up, but we happen to
Yeah,
have
sorry.
Jazz Banga, on the line, and obviously this area of counter UAS and everything else is one of his areas of expertise. So Jazz, I'll defer to you real quick there.
Thank you. This is an issue that's pretty near and dear to our hearts, both on the fact that we have similar issues even with MLB, right? When you have these stadiums and there are drones near those areas as well, we just don't know who to contact. I think if you look at even the founding of the Drone Advisory Committee, this was brought up very early on with Hoot Gibson as well. And our question was, well, who do you talk to? It's not an FAA enforcement issue. DOJ doesn't seem to pay attention to it. And then local police don't know what to do with it. So I think if anything, our questions before we can take action, whether it's mitigation or whatever else, the question is, what's the procedure? Like, who do you contact for reporting? How do we even get the data about how frequent this is? I think if anything, the email exchange opened the eyes for a lot of people was how prevalent it really is. So that's my comment on this, and just asking, we'd love some guidance on this and any way we can help, because this is a big issue.
Excellent. So I think we duly noted. I think we captured. Yes.
Just one comment, and this may sound very obvious, but having spent the last 8.5 years as one of the largest drone service providers, can we make sure we actually have service providers at the table? We're talking about counter UAS, because oftentimes those folks get left out. And those are the folks that are actually flying for legitimate purposes to do infrastructure inspection or security. And so having those people at the table, and not just hardware folks and not just software, but real operators, folks like Tom Walker at DroneUp, for example, at the table is critical.
Excellent. Thank you. And we'll certainly take this offline and do some follow-up here to see if we can make some contact. So thank you all, for that item. The next item that was brought up was, and Jay, maybe you can address this, you and Abby and team, what are the priorities of tasks remaining from the 2018 FAA Reauthorization Act, particularly relative to things that DAC needs to be, providing for you and the team or the AAAC?
So I think the best thing we could do is just give a brief on where we are with all of those, all of the tasks that we were given in reauthorization. As I think most of you are aware, the executive branch is prohibited from lobbying Congress. So I don't think it would be a great idea for me to task this committee with what Congress should be told. But what we can do is tell you where we are, and we could have a conversation about that and maybe some things we see, that would be, I can take an action our next meeting that we give you an update of where we are with those tasks and reauthorization.
Excellent. Any other thoughts on that? I know, excellent. All right, the next one was, what can the FAA do to speed up the rulemaking process? I know several members who brought this up before. So this isn't a new conversation, but, everybody's smiling, I understand.
Where's Bob's box of
We're-
tissues? Okay, again. So let me think about that one. As you heard Deputy Administrator Mims say, one of the things that we're looking at with the BV Loss ARC recommendations is we realize that we can't continue to do things serially anymore. There's a real need to figure out how to do, some portions of these. Obviously, some things need to be done, first, second, third, that sort of thing, because they build on each other. But we're looking at that. We're also looking at ways we've realized that, particularly in the drone area, if we try and make the one rule to rule them all, we just get bogged down. So the other thing we're looking at is in our rulemaking strategy is how do we break it up into the chunks that we can do quickly? We're almost, I hate to use this term from software development, but we want to get away from the waterfall model and get more to the agile model. We also realized that we had too much of a mentality that we tried to create the ultimate rule that would never get changed, right? So we're now starting to admit to ourselves, let's get a rule out. Let's let people start using it, get feedback, and then maybe we look at changing things. And if we're making smaller rules, maybe we have more opportunity to get those sort of things out. So those are some of the things we're considering. I'll take that one back and put some thought into it. And I think if any of the probably everybody has energy around this, but maybe we can have a discussion on like how to focus that, because it would be, I think it could also turn into such a broad scope that we don't make much progress.
So Jay, along that line, I don't know if you can actually comment on this, but on the ARC recommendations, have you already broken it out into sort of provisions that are non-controversial, to be done through sort of a...
We're in the middle of that process.
Okay.
And what I like about my new boss, or I've got lots of new bosses, but Dave Bolter, who's acting as the head of aviation safety, he's a very pragmatic person. I liked my old boss too, don't get me wrong. He was a great guy. But he also wants to look at not just drones, but he sees the continuum from recreational through 107 to what the ARC called 108, to Mosaic, to powered lift, to remotely piloted vehicles, to autonomous vehicles. And he sees that we need to be thinking that as a full set, and that if we just look at drones or AAM alone without thinking about how all these things interact, and where are the points that maybe it's the tipping point that you move to this rule set or you stay in that rule set, we're going to make a lot of mistakes. So I'm really grateful that we have that kind of leadership that's thinking about a comprehensive set of rules. The other thing Dave's really good about is when you listen to him, he'll talk about the complete rule set, which isn't just regulations. It's advisory circulars. It's guidance to people who execute the work in the field. And you need all of that, not just the regulations. So that's where we are. I sort of took more time than I should have.
No, very, very good. So certainly an opportunity. And I know, Kathy, you brought this next one up. You want to maybe expand on that a little bit, just kind of background and thought process?
Okay, so the question is how we can operate in Class E over A airspace. Because right now we're being...
Is this what we commonly refer to as upper E?
I think so, but this was a term that we'd heard recently in terms of operating E over A. And
Yeah.
that's in the XTM, it's described as E over A. So In E, of course, see and avoid holds.
Right.
And we can't see and avoid because we can't get aircraft high enough to keep human eyes on the aircraft. But you have to go through A, which is completely communicative. So why can't we keep going communicative into E, which would get us away from the see and avoid
So,
issue?
so let me also take an action item. NASA and the FAA have done some thinking about this. And we have had some vehicles that we've enabled to operate in that airspace, and we've got some lessons learned. So maybe let's think about a tasking. But I think it would be good to bring FAA and NASA to kind of tell you where they are in their thinking. Well, where all of us are. I don't mean to exclude myself. I'm a part of that large ecosystem.
Yeah, doesn't ICAO have a job card open in this area?
Yeah.
As well.
Yeah, they do. I'm not sure where they are in the process, but I don't think they're very far along yet.
I believe you're correct, but that would be good if we could.
Yeah,
integrate
we'll
that
include
piece in
that.
as well. Yeah, thanks.
Absolutely. You know, where ICAO is with this.
Okay, great. Dr. Chu, I know you had a thought that you want to share as well.
Yeah, well, thank you. Thank you, Chair Mel. This morning, lots of discussion about the alternative fuel. Currently, my team is actually working with the United States Air Force and one of their private contractor to develop and testing the world first 100% synthetic jet fuel. It created by carbon capture, which is out of the thin air. It sounded unbelievable, but I actually, the last year, we're watching this development and it's kind of real. And the testing with we provide the small jet UAV. So it will be, this will be the third test, going to be in the next couple of weeks. The project really was pursued by the relationship with the current administration's call for less dependency on fossil fuel, especially in the jet aircraft. I always question about, you know, what's the quantity of these things? Just 10 minutes ago, I keep asking a question, the Air Force answered it. They said they are currently developing a plan to produce 500,000 gallons of this synthetic jet fuel. It just, you know, it sounded really exciting. That's why I want to use this opportunity to, you know, Jay talked about the technology transfer. And I also keep thinking, you know, what can FAA or AAAC play a little bigger role in facilitating this UAS participation in the in this groundbreaking innovation of this alternative carbon neutral fuel solution. So that's something that we really need. And just quickly, another thought. Last night we were gathering and Joe and I would talk about it. You know, when you talk about AAM, you know, there's I'm pretty sure you guys know about this. There's a old technology. I've been learning about these things just like 4 years ago about quantum sensors. And these things are just really out of this world. You know, they can predict the smallest items for time, quantity, transportation, you know, pressure, rotation, acceleration, frequency, and magnetic and electric field. And then the beauty part about this is you cannot jam the things. You know, GPS, you can jam it. And so when we talk about AAM, maybe we should think about that too. So anyway, that's just my thoughts.
Well, thanks, Dr. Chu. So certainly just wanted to have the opportunity, and these are thoughts that everyone's kind of brought forward. So we'll catalog these and certainly could provide a genesis for future conversations and taskings as well.
Absolutely. And Houston, I would make the offer that, you know, maybe through conversation today, you got these prior to today's meeting. if people have additional thoughts, I'd love to get those.
So there is definitely a list of thoughts that have been gathered. So we'll forward those and please keep them coming. Next slide, real quick, if you don't mind. Just one last slide. And that was really just, one of the things Jay has asked, for us to do is provide some potential FAA tasking recommendations. And so there were a couple that we pushed forward. I won't go through those, but just for, the committee's review, you should have these documented. So we pushed these forward to Jay. Again, I'll also share the consolidated list, which also has some potential feature taskings, for us to consider. So Jay, thank you for the opportunity, to solicit the committee for input along those lines. So with that, we'll move on to Jay for closing comments.
Yeah, and I know we're tight on time, so I won't be overly loquacious. I do want to thank the committee for your hard work. It was great to see everybody, at least all of you who could make it. For those of you in the Brady Bunch view, hopefully next time you can be with us. As the deputy administrator mentioned, we expect by the next time we meet in December that we'll have additional members as well. So I was also struck, and I mentioned it to Houston, there's a tremendous nexus between the gender neutral language work, and now we call it gender inclusive in the FAA, and the K through 12. And I think this committee should really take pause and realize how much you've become a catalyst to the FAA for new thinking. And it's not just technology, right? I think it's remarkable that some of the biggest impact you're having is on the softer side of things, as we often call them, not on hardware, but on changing the people and changing the system. So thank you very much for that and your leadership in this area. And with that, I look forward to seeing everyone next time, and I turn it over to you, sir.
All right. Well, again, Jay, thank you. A couple of thank yous first. Thank you again to Task Group 12, for the great work, Brian, Dr. Shu, Abby, for the great review, the recommendations, David, you and Salita, and all Task Group 13 for the interim report. Looking forward to the ongoing activity from that perspective. Carrie, Janetta, thank you all. Having airport properties here to really kind of broaden the perspective of the group was very insightful. I think we learned a lot and really will help us move forward. Bob's already left, but certainly want to thank him for coming and providing a NASA perspective in terms of how it integrates. Certainly for all of our guests online, those who weren't able to be here, I want to thank you, all the members, right? It's just a group of thought leaders that take your valuable time. Everyone's obviously got some pretty high power, busy day jobs, but for you to collectively come together to provide the resources needed for us to really, Jaywan, to your point, ensure our leadership globally stays in place and provide the FAA, thought leadership from a variety of stakeholders to help ensure that is very a powerful proposition. And lastly, I want to say thank you to the FAA staff. Special kudos to everyone who's put this together, and big round of applause. Especially to our man, Gary and his team just do phenomenal work, making sure we're all prepared. And Gary, just want to personally just say thank you because I know all the stuff. So with that, UPS on time, 2:30 exactly. Turn it back over to you.
Is there a motion to adjourn the meeting? A second? All right. Any objections? Meeting is adjourned. All right. Thank you.
All right. Thank you.